Yeah, hi, good morning and good evening, everyone. So we completed stateful set and Helm charts last time. So Helm chart is for two purpose. One is as a Kubernetes package manager, and the other one is to parameterize our Kubernetes manifest files, and we will configure Helm for our RoboShop as well. So today's topic is RBAC, role-based access control. Okay. So this is the universal topic, just like I am in AWS. Okay. So any system, two things are important, that is authentication and authorization. So we know this very well in our companies also. So all of us have ID cards. We have access to the main entrances and our project and project cubicles, but we cannot access other projects. So authentication is you are entering your company. Authorization is you are accessing your project space. Okay. So authentication, you need to prove yourself. Authorization, you need to prove you have access to that particular resource. So in Kubernetes also we have role-based access control. So till now we are doing everything with administration access, but that is not possible in real-time projects. So you should have your role and permissions. So here there are four objects, that is role, role binding, and then cluster role and cluster role binding. So, we have multiple resources in AWS, the like pod, service, deployment, stateful set, PV, PVC. So these, out of these resources, few resources are namespace related, few resources are cluster related. Okay. Yeah, we have many resources. Config map, secret. So pod is namespace related. So it is bound to namespace. Similarly, service, namespace. Deployment, namespace. Stateful set, namespace. But PV is not namespace. This is cluster level. Okay. PVC is again namespace. And config map is namespace. So if you just see here, QCTL API resources. Okay. So here they mentioned dash true and false. Okay. Config map. Namespace itself is obviously not namespace related. Nodes is obviously not namespace. And then persistent volumes. Persistent volume claims is but namespace. So what I mean to say here is here there are multiple resources, namespace or namespace cluster level. Okay. Okay, so in Kubernetes, resource is either namespace level or cluster level. Okay. So just understand these roles. EKS, it's not only for RoboShop, any project can create their resources here. RoboShop, Amazon, Flipkart, any number of projects. Okay, because it's a platform as a service. EKS is not AWS native service, it is a platform as a service. The original thing is Kubernetes. So AWS created EKS as part of their cloud offerings. Okay. So, but you must understand this is a platform. Platform as a service means it has its own set of rules and regulations. So one EKS cluster, you can configure many number of projects. So there will be EKS admins. So they have full access to entire cluster. But RoboShop, when it comes to RoboShop project, so we have multiple roles. RoboShop admin, RoboShop developers, so you can create any number of roles around this RoboShop namespace. So this one is like DevOps and cloud engineers, full access to the namespace. This one is RoboShop developers, limited access. Okay. So this is the system. How can you create this kind of accesses? Like first thing, I am administrator. Okay. So RoboShop project is started. Project started. So then what will happen? Team leaders, managers, or DevOps guys, they send email to create namespace and provide access. Okay. Just assume EKS cluster is already exist. So it has running multiple projects. It is running with multiple projects. And then RoboShop project is started. DevOps engineers or team leaders, they sent email to EKS administrators to create namespace and provide access with necessary approvals from the higher management. Okay. So now EKS admin responsibility is to create namespace and give them the access. Okay. So now let us go and so this is administrator access. Okay. So this one. So this is administrator access 21.79. Okay. So now let us understand how can we do that. So first thing, create namespace. So what I do here is K8 RBAC manifest.yaml. Or else I can say admin.yaml. So here first we need to create the namespace as admin, as EKS admin, create namespace. Okay. So we have our namespace creation. And then after that, so we need to create these things to provide access: role binding, cluster role, and cluster role binding. So here a simple twist in EKS, because AWS is cloud, EKS is platform. Okay. So AWS has its own authentication mechanism, IAM, and RBAC is for authorization. So generally, if it is on-premise cluster, Kubernetes, both authentication and authorization, you will get it from EKS, but since it is incorporated into the AWS, so what AWS is telling is, so we cannot create, because EKS is one of the platform as a service. Similarly, AWS can get lot of platform as a service like other things. Okay. So EKS is one of the example for platform as a service. And we have something called IoT as platform service. So AWS cannot go and create different usernames and password in all platforms and IAM. So what AWS did while incorporating EKS here is, so they used IAM for authentication and RBAC, Kubernetes RBAC for authorization. Okay. So now you should have IAM user and you should have role-based access control. So you need to map IAM and K8 role-based access control properly to get the authentication and authorization worked. So now first what I do here is, for authentication, I will go here and then in users, so I'll create one user like Ramesh. So this user, he should have access to this. What is our cluster name? So EKS pod cluster is our cluster name. Okay. So this Ramesh should describe this cluster. Because he at least needs to see the cluster to get the access. So here, when I created the user, I need to attach policies, create policy, and then here select EKS, and he needs to describe cluster. Say this, describe, and then which cluster in this account, and US East 1, and our cluster name is this one. Okay, next, and just give a name, EKS pod cluster describe. Okay. So your cloud account may have any multiple clusters, but we are giving access only to particular cluster for this user. EKS spot cluster describe, next, and then create user. Now if you see here Ramesh, and then the permission here for him is he can only describe this particular cluster. Okay, so yeah, so this is for authentication, not for authorization. Okay, so I am user is created, and then role and role binding, role and role binding in Kubernetes. Yeah. So general meaning, it's not anything complicated here. Role, every role will have permissions. For example, so in taking projects, we have team member, and then like what are the roles we have, like trainee, and then junior engineer, and senior engineer, team leader, manager, something like MD. Okay. So these are the roles we have. Based on the role, we will attach the permissions. For example, trainee, we will only give read. Junior engineer will just give some elevated access. Senior engineer, some more elevated access. Team leader, some module admin access. And then entire project. So he will have entire project admin. And this guy may have, MD may have multiple projects admin, entire account admin. Okay. So something like this. This is the role and these are the permissions. So similarly here, we need to create role and we need to define the permissions. So let us take this example. Okay. So we are creating role. What is the namespace? RoboShop. And then what is the role name? For example, I'm going to create RoboShop admin. So admin means in this namespace, you should have access to the everything. So you can give here star, you can give here star, and then you can give here star. Okay. So here three things. API groups. You know the API groups here. We already have seen this, right? So you can restrict access based on the groups. For example, if you give V1, so he will give access to these resources. Okay. So out of API group, what are the particular resources you want? You can also again control the access, like only config maps, only pods, only secrets. So you can restrict access to that. And then what are the verbs? Verbs is nothing but actions on resources. What are the actions on resources? Like create, read, update, delete, generally CRUD. We call it as CRUD, right? So creation of resources and deletion of resources, it means it is too much access. Just read is minimum access, update is medium level of access. So as an admin, he can do anything in this RoboShop namespace. He can go to any API groups, any resource he can create, any action he can do. Okay. And remember, this is only for RoboShop. It is namespace level, not a cluster level. And you need to bind this to some person. We created role and permissions. So similarly here we created role and permissions. Now what I have to do, Sivakumar should have trainee role and someone Ramesh should have team leader role. So this is called binding. You are binding a person with role. So this role have permissions. So automatically Sivakumar will get these permissions. So that is called role binding. Okay. So now we need to take role binding. So let me take that as this one. Just showing these things. Namespace, RoboShop admin. Role binding name is also RoboShop admin. And then what is the username? It is going to be Ramesh. And then role reference. So you are mapping Ramesh with this role. What is the role? We have given here RoboShop admin. Okay, so that's it. So this is namespace, role, and role binding. We need to create these two objects, these three objects. So let me push this cd slash c slash repos k8 r back. Hit init, create repository k8 r back. Add origin. Just pushing and link here. kubectl apply -f admin.analyze. Error validating data, API version not set. Something is wrong here. API. Okay. Git pull. Role is created. Oh, again some mistake here. Sorry. This is not RoboShop admin. This is RoboShop. Thank you so much. Some of you already spotted the error. Okay, so now this is done. So I created I am user, I created role and role binding, but I haven't informed anywhere about EKS about this I am user. So generally, whenever EKS cluster is created, there is some config map called AWS auth in kube system namespace. Okay. Config map AWS auth in kube system namespace. So here we need to map I am user and Kubernetes RBAC. Okay, so we need to inform AWS auth config map about our I am user created. Okay, so otherwise EKS is not aware of it. So kubectl get config map AWS Arc -n cube system -o output format into YAML. So this is our thing. So whenever EKS cluster is created, you can see this. So this got by default administrator access. Okay. So with the user, whatever you created. Okay. So now I'm taking this. You can just refer AWS documentation, AWS EKS IAM. If you just see this, AWS EKS IAM permissions. So they will just give us something. How to get IAM user map with details. Okay, so this is the documentation we get from the AWS. So what they say is edit the AWS authentication config map. You can use such as tools like EKSCTL to update the config map, or you can update it manually by editing this. So you can just work on this. Obviously, editing config map manually is not a right thing. You can just go ahead and then explore these EKSCTL commands while you are working as a practice. Okay, for simplicity, right now I'm just editing this manually. Okay. So what they say here, they are just giving this section. You can see map roles is already there, and there is something called map users. Just copy this and take this into VS Code. So what they are saying here is copy this section, and then here you can mention any number of users. Right now we have created one user. Okay. So this user, this is the name of the user here. So this should be the role, RoboShop admin. Okay, and what is the user AR? Go here and then get the user ARN. And what is the username? Ramesh is the username. So now what does it mean here? So this, I'm just informing EKS cluster. So there is a IAM user, and I'm giving him RoboShop administrator access. It means this is the role and the username is Ramesh. Okay. So just take this and what they say here. So edit it and then add the IAM user. So this is the example and save the file. So I will just apply it. Just give it here. Just give here in our YAML. it will this is warning. It is fine. So there are some warning is fine because here there are some UIDs and creation time. So those will be automatically adjusted. Okay, this resource version, everything will be adjusted. Now you can see resource version is changed. So it gave warning and it automatically adjusted and then it added some. So this is the configuration. Some metadata annotations it added. Okay, no worries. This is just a warning. So now this mapping is done. So now we need to test this. How can we test this? I'll just create one EC2 instance for RoboShop project. So till now we are acting as admins. Now we are RoboShop persons. So this Ramesh, we need to create one security credential, create access key, command line interface. So this is the Ramesh. Take the RoboShop instance. Now, how can he access the cluster? Just AWS STS get caller identity. So till now we haven't configured, right? Caller identity will just tell us what is the AWS user he logged in. So he didn't log in. Just run AWS configure and give this access key and secret key. US East 1 10. So now if you just run this command, it will tell what is the user you logged in. I used Ramesh. Now there is a EKS update kubeconfig command we know, right? So just if you run this, this will be automatically created. Dot kube and config will be automatically created. Just run this command and give which region, what cluster. US East 1 and then EKS spot cluster. Okay. Now, if you just mention kubectl get nodes, oh, this is not installed. Then what we do, we install kubectl all our workstation kind of things. Perl sudo bash. So it will install all kubectl and then Docker, Helm, Kubernetes, everything. So wait for 2 minutes. Okay, everything installed. kubectl get nodes. So what is it saying? Do you think so this is success or not? So nodes is a namespace resource or cluster resource? Please answer in the chat. Nodes is a cluster resource or namespace resource. So obviously it is cluster resource because it's not namespace actually. So inside nodes, we will have namespaces. So we created role and role binding so that give access to the namespace, but not give any access to the cluster. So what we do, we will give limited access. We don't give persistent volume creation access. We don't give something else. Okay, we will give limited things like he has to at least see what are the nodes available and what are the namespaces available. Okay, let us go here and then there is something called cluster role and cluster role binding. So here we will have cluster role. So I'm just giving it as RoboShop cluster reader. So what are the objects they can get? Let us see nodes kubectl API resources. So at least he needs to see what are the nodes available. So this is the core one. And what are the namespaces available? The namespaces. Where is this namespaces? Correct, namespaces. So this is also inside group and persistent. So this is also inside core group and stateful set. So this is inside apps/v1. So we will give access to v1 and apps/v1. So these two, and the resources will be secrets and what else? Nodes, namespaces, and then persistent volume. So it is up to our wish, okay, what we give access as an administrator. So he is getting only get watch list. This is completely reading access. So it will not give you any create, update, or delete. So that one, it will not give any access. And we will give role binding also. The role binding is obviously important. So this is cluster role binding. So RoboShop cluster reader, the namespace. The cluster role, you don't need to give the namespace here because obviously it is not a namespace, it is a cluster. What is the subject here? Subject is user. The user is Ramesh. Okay. And then what is the cluster role? This one. Okay. For this cluster role and for this user, we are mapping. Now you push and you pull here and you apply. So this is AWS we applied again. So obviously it got error because it is already exist. Let us once just so AWS auth, you just keep it separate, okay? Don't keep it inside here. Yeah, we have this one exist. So it means we applied the things. Now just give kubectl get nodes, log out and log in again. Kubectl get nodes. Still it is not happening. Okay, update the maybe we didn't give this one. So it is saying API group empty. So we should give API group empty. It full. That's fine. AWS authentication. Now, yeah, now you can see. So this nodes, they are saying it is API group empty. So I just gave that. So now we have given bare minimum access inside to read the cluster level resources. Okay. Now kubectl get namespaces. You can list down kubectl get pods -n RoboShop. But let us see he can get any pods in default namespace and any pods in kube system namespace. So he is not getting access. He only can access his namespace as a RoboShop project. So this is how you can work on Kubernetes role-based access control. Just assume if you joined as RoboShop DevOps engineer, you will follow this process and you will get the access. Then you can do anything in your project. Similarly, you can create access to the developer. So developer, then what you do here, so developer, you will limit it, get watch list only. You will keep the verbs here. Okay, so now I think you know how can you create the role for RoboShop developer. Just take it as assignment and then do it. Okay, so steps you follow, you create another user like developer, and as an administrator, you give only read access. You don't give any administrator access. Okay, and for developer, you no need to give any cluster role and cluster role binding. Okay, so that is how you can limit the developers. So this is the Kubernetes role-based access control. And then so we'll implement these concepts with RoboShop. Okay. First, we will complete the concepts. And the next topic is, I'll do one thing. I'll go to this users, Ramesh, and then deactivate this because it's already exposed. Okay, so that is all about RBAC. There is only 4 things: role binding, cluster, and cluster role binding. And then I am AWS, I am an EKS mapping. Okay. And after RBAC, so we will discuss horizontal pod autoscaler. So what is this horizontal pod autoscaler? So we know we have replicas. So you can mention 1 or 10. So if you mention 1 replica, so does it scale automatically if the traffic is more? Please answer me in the chat. So if I mention 10 replicas, assuming high traffic, so if the traffic is reduced, does it scale down automatically? So no, based on what purpose you can scale up and scale down the pods. So that is something called, generally, you know, that CPU utilization, or memory utilization, some metrics you have to provide. So if the CPU utilization is more, then you can understand that there is a lot of load on the pod. If the memory utilization is more, there is a lot of load on the server or pod, whatever. So this is task manager. This is my task manager. So what is the, what is this? So this is my task manager, right? So now the memory utilization is 39%, CPU utilization is 38%. So if it is reaching continuously 90% CPU and 90% memory utilization, then obviously it means I have to change my laptop. So this laptop is not sufficient to handle the work I am doing, right? So right now it is 32 GB RAM. So obviously it is good, okay, because it's a powerful laptop. So I used to buy ThinkPad laptops. I don't like new laptops. Generally, I take second-hand laptops and then I will use it. So, based on, you have to continuously monitor what is the CPU utilization, what is the memory utilization of the pod, so that you can estimate what is the traffic on your servers or pods. So you remember this AHA issue. So last time when they published Prabhas interview in AHA, suddenly everything is crashed. So maybe they haven't properly implemented these things, CPU utilization and memory utilization. So now we will do that. So to do this, for example, just now you can see kubectl get pods. So first we need to deploy our resources, right? First thing, so we have K8 RoboShop. So let me take K8 RoboShop. We have all the components here. Part catalog, everything. Okay, so now what I do, I will just make it up and running. So since this is RoboShop namespace, let us try as RoboShop engineer only, not admin. Okay, cd mongodb kubectl apply -f manifest.yaml. kubectl. Oh, sorry. I just now deleted the user, right? So it's fine. Let me take as admin only. A8 Photoshop for MongoDB, and then catalog, or for MongoDB Redis I in MongoDB Redis, MySQL, RabbitMQ, catalog, cart, user. What else we have? Shipping, payment. Thank you, Mahesh Golla. There is a typo here. MySQL, and then web to cd $I kubectl apply -f manifest.yaml cd one step back, and then done. Okay, so everything got created. There is some tool called K9s. So this will give you generally UI to our Kubernetes. Generally, I don't like UI, and you also don't like it because that will kill the concept. But this is a bare minimum UI. You can use this, no problem. How can I install using Linux? Yeah, just run this script K9 K9s. Okay, once you install, you just run K9s. You can see this. Okay, so these are the pods running. Cart, catalog, MongoDB, MySQL, everything is running. Okay, so these are the namespaces. Okay, left, this is namespace, and this is the pod run. Okay, if you just want to go another resource, you can just shift : and I'm just typing pods. Now I can see pods in all namespaces, and you can see here there are the options. Okay, now if you want to see the catalog logs, go here and just press L. Okay, escape. Now if you want to see the service, shift : service. Now you can see this is the endpoint created. Okay, so this is up and running. Now imagine people started using our application. There will be a lot of load on this. How can our pods behave? Okay, so there is something called Apache benchmark to test Apache benchmark installed. So this one, what it does is it will simply generate load, and then it will give you statistics. Okay, so how much load your application can serve. Install HTTP tools. So just I'll take one more session. DevOps 321 K9s. Namespace. I'm selecting RoboShop namespace. Okay, and here installing Apache benchmark. Okay, so this comes from HTTP tools. So this will be installed. How can you generate load? AB is the command, -n, number of users. So it means like it is 10,000 users sending 100 requests parallelly. Okay. Now let me just give AB -l help. So if you can see -n, number of requests, -c, concurrently. So it means concurrently 100 users are sending 10,000 requests to our system. Now this is the URL. So you can see it is 82 milliseconds is the longest request. So our application is able to handle those many requests. Now let me increase this. 1,000 users. So it is we have to calculate how within how much time our application should respond. Generally, if it is e-commerce, so there is no limit. So we should need as fast as possible. If Amazon is responding fast and Flipkart is responding slow on a big billion day, so obviously entire business goes to Amazon. Okay. So now you can see 3,357 milliseconds. It means it is around the longest is this one. Okay. And the 50% of the requests got 228 milliseconds, but the longest is taking 3.4. So this is average performance. Let me increase. So it is not even able to open that. So let me give 5,000. This is also because this T2 micro is also not enough to send these many requests. Okay. So out of 1,000 users accessing and then sending 1 lakh requests. Okay. Now, what is the longest request? It is say taking around 3,000. It means 3 milliseconds, 3.3 seconds. So generally that is more. The best thing is the first one. Okay. Because here the number of pods are very less. It is not able to handle that much load. So for that purpose, we need to implement horizontal pod auto. So what that one is doing is, first thing the condition is you need to have metrics server. Okay. Why we need metrics server? Because metric server is able to calculate the resources. Now, if I see here, kubectl, what is the command? Top is the command to give what is the current resources consuming, percentage of CPU, percentage of memory. So similarly, kubectl top pods. It is saying metrics API not available. So it means, so there is no metrics server to calculate the pod resources. So we need to install metrics server. So install metrics, or let me say horizontal pod autoscaler. Horizontal pod autoscaler. So these guys, they assume already metric server is installed. So you also need to use a cluster that has metric server deployed. How to deploy metric server? Now you can see this. Okay, installation is very simple. Just apply this. Okay. Coming here, applying metric server. So metric server is created. Now you can just run this command. So it is just created. It will take some time. kubectl get pods -n kube system. So inside kube system, there will be metric server. It is still run. It is still not ready. Let us wait for it to be ready. Okay, now it is ready. Let's get here. So now you can see it is able to calculate the number of CPU cores consumed and number of memory bytes. So another condition is you should mention the resources. So let me take it here. Go to the K8 RoboShop. For example, catalog. So here you remember I mentioned giving resources is the best practice. Otherwise, your pods can eat entire resources. So resources and then requests. This is a soft limit. And this CPU I want is 50 milli CPU and memory is 68 MB. Okay. Similarly, you have to give hard one limits. CPU should be 100 milli max and then memory is 128 MB. So now if you give these resources, this is the condition. Okay. Then based on this metric server and the things here, it will calculate the average. Okay. Right now, COT is using 0 milli. Web is using this one. But because nobody is using it, now let me send these requests again and give watch. Or else just give K9s. It should get here generally. Yeah. So now you can see CPU memory is displayed automatically. So now what I'm doing here is I'm sending 10 lakh requests slowly. Okay. 100 concurrent users. Now you can see there will be an increase in the CPU and memory resources. Now you can see you are not able to understand what is the percentage of CPU by request, percentage of CPU by limits. That is because you haven't implemented this request. If you don't implement this, then metric server is really not able to calculate that. Okay. So it is our responsibility to give this one for catalog and web, obviously for everything. So I'm implementing for catalog on web, at least we can see. While you are practicing, you implement for everything. Okay. K8 RoboShop. You can see here, it is increased up to 77, but we need this for average. Now, see, git pull. And then cd mongo, cd catalog, kubectl apply -f manifest. Okay, so this is configured, and similarly web kubectl apply manifest. This is configured. Now it will take some time. Now you can see those metrics are available here. Catalog is coming. Yeah, for catalog also available. So now once this metric server is installed and you implemented the resources section in your horizontal pod, so now you are able to implement this horizontal pod autoscale. Okay, so let me go here and take the same thing. So you should have deployment and service. So deployment should be installed automatically. I mean, deployment should be available. So on top of deployment, I'm just informing Kubernetes. I'm going to run horizontal pod autoscaler. The name is catalog, and then deployment. This is going to target catalog. So this horizontal pod autoscaler continuously watch catalog deployment, and then it will check for the resources, how many resources it is consuming, and minimum replicas 1, maximum up to 10. And if the CPU utilization is more than 75%, increase up to 10. If CPU utilization is less than 75, decrease up to 1. So that is the simple meaning. Okay, so now everything is available to calculate. Just you need to run this. I will apply this for web also. So instead of catalog, I'm just mentioning it as web, and then web. Okay, that's it. Now push, pull, and apply. Apply. So horizontal pod auto scaling is created. Now your deployment is able to handle the load automatically. So now let me send the number of requests. Now let us monitor here. So it will take generally some time to reflect. So it shows refresh. Usually it takes some time, but it's fine. Now you can see that it is increased. See that? Now automatically it should create the pods. 100, and it reached 200%. Now the pods should come up. it not happening? Oh, didn't come up. Anything wrong here? kubectl describe -n RoboShop. Ah, the mistake here, I didn't mention namespace. Okay, so that is the mistake. Go to catalog, mention namespace, push full apply, and then go to web, apply. Now increase, put some load on it. Now you should see that. So obviously databases uses high memory. So that is why we should not keep generally inside Kubernetes. Okay. Now you can see, so this got created automatically. Web. Now two pods are running. Now third one also created to handle the load. So up to 10. The catalog is sufficient generally because too much load on the main URL. Now 3, 4, 5, 6, 6 pods are created to handle the load. It will go up to 10 because we gave 10. So now let us increase this to 10,000. So here how many will be? 100. Here we will do 1,000. The longest request is 15 seconds. And 50% of the requests got. So percentage of the requests served within the time. So 15% of the requests served within 28 milliseconds. What is this? How can we understand? 3, 4, 5, 6, 7, 8, 9, 10. So to handle the load, we got 10 pods created. Now sending once again. But catalog only one is sufficient. Okay. So this is how you can automatically increase, and after some time these pods will be automatically deleted because there will be no requests. So this is horizontal pod autoscaler, important for interviews. Okay. It will take some time to refresh also. Maybe the pods were deleted, but here it may be not refreshed. So slowly these pods will be deleted. Okay. So just they will be standby, maybe to handle the load, and after some time they will be deleted automatically. So this is how you implement horizontal pod autoscaler to handle the load. So this is very important for interviews. So you can say we did some benchmarking using Apache benchmark tool, and then so we measured the, so we have our target response should come maximum within 2 or 3 seconds. So based on that, we replicated the concurrent users and the number of requests. Based on that, we implemented horizontal pod autoscaler. So that should be attached to the deployment. And 75% is the maximum CPU utilization for us. So the next thing is ingress control. So what is this ingress control? So you know what is the load balancer? It is getting created whenever I give service as load balancer. Someone please answer in the chat. What is the load balancer? It is getting created. Application load balancer or classic load balancer or network load balancer. So first let me delete this. So in Kubernetes, not the load balancer we already work in Kubernetes. What is the load balancer? It is creating. So this one is a classical load balancer. Okay. So classic load balancer is the legacy one, previous generation. Okay, so AWS is not suggesting to use this classical load balancer, and you know we already used application load balancer, but Kubernetes automatically it will create classical load balancer only. But application load balancer has many users compared to the classical load balancer. It is intelligent, so it has the multiple routing mechanisms than classical load balancer. Classical load balancer is not intelligent. Classic versus application load balancer. This is a very important interview question. Table. So application load balancer, it is layer 7. Layer 7 is the top in the network diagram. And then you can see the target type, IP address, instances, and Lambda, and it is redirect. It has a lot of usages actually. So based on the headers, based on the URL path, based on the context host path, you can route a single load balancer to multiple projects. So to reduce the cost and to improve the intelligence, application load balancer, for example, Amazon dot join DevOps dot online. For example, in our cluster, we have Amazon. So it can go to Amazon project. Flipkart dot join DevOps dot online. So it can go to Flipkart project. But if you implement classic load balancer, you have to implement a separate load balancer for each and everything. And based on the headers and so based on the path also, you can redirect the application to multiple things. For example, we have m.facebook.com. So what does it mean? So this means mobile site. So if you receive a URL like this, redirect to the mobile application, mobile website. So if it is facebook.com, redirect this to actual application. So if it is admin.facebook.com, redirect to administrator website, Facebook admins. So a single load balancer can handle heavy amount of load and it can redirect to multiple applications. So, but classical load balancer cannot do that. AWS always suggests to use application load balancer. Okay, you can just read this. So if you have any old applications, you choose this. Otherwise, you choose this one. Okay, advanced routing capabilities. So now, since it is automatically creating classic load balancer, we don't prefer that. We used to create ingress control. So how this will work? Ingress controller. Ingress controller. Already something. Okay, maybe from previous batch, but fine. So user hits our Amazon Route 53, like admin, like Amazon dot join DevOps dot like app. I'm just replacing this maybe from previous batch. App1 dot join DevOps dot online, app2 dot join DevOps dot online. We have two applications, application 1 and application 2. So this is our EKS cluster. This is our load balancer. Okay, application load balancer. So Amazon Route 53 is sending request to application load balancer. Here there are two rules. If the request is app1.joindevops.online, a new resource is there, ingress. So this one, the request will go to this ingress, and from here it will go to this service, and from this service it will go to this pod. Okay, so ingress is required as a new resource because it is handling the routing. So ingress is a resource required for ingress control. So what is that ingress? We will see that. Ingress Kubernetes. So we need to inform, right? We need to inform Kubernetes when there is a request. This is context part. There is something called host one. So you can see if there is a request star.foo.com and accessing foo project, it should go to the foo. If there is something called bar project, then it should go to this one. Okay, so here documentation is a little bit confusing. I will make it clearer. Okay, so there is two things, host path and context path. This is host path. Okay, so host is different here. If you see, domain is same, but the host is different. Amazon, Flipkart. What is context path? Context path is nothing but this one. This is context path. So you can select whichever you want. So this is host path. So this is context path. If it is slash Amazon, it will go to the Amazon application. If it is slash Flipkart, it will go to the Flipkart application. This is the context path. This is the host path. If it is Amazon dot, then it will go to the Amazon application. If it is Flipkart dot, then it will go to the Flipkart application. So there is an extra resource ingress you need to create. So now let me create another repo K8 ingress. Okay. So here what I will do, so I will create two applications and then I will control the access for it. Okay. New repository. So we'll complete this and then create the session. Okay. K8 ingress. Git init, git remote, add origin. So now I will take, I'll take app1. So before that, I'll take Docker, I'll create one Docker file. So this will be, where is this Docker? So too many repos. Where is this K8 ingress? Yeah. So this Docker file is app1. Let me create two folders. Huh? App1 and this Docker file belongs to app1. So I'm installing Nginx and then I will remove that, run rm-rf user share nginx html index.html. I'm removing this. Okay. I'm just mentioning, hello, I am from app1. Okay. This will be with big text. So I will similarly create app2. This is just an image, okay? Just to understand from which application it is coming. So I'll build these images. Git clone 8 ingress cd app1 docker build -t join DevOps / app1 : v1. just logging in, Docker login, join DevOps, password, and then Docker push, just push this image. So just remember in Kubernetes, two things only, image and then manifest. And I'm going to app 2 and Docker build app 2 colon v1 and push. Okay, so we have the images available, app 1 and app 2. So now I need to write the manifest dot YAML. So here deployment and then service. Okay, so let me take the K8 resources. Okay, so to deployment, just taking one deployment. So this is deployment app 1. Okay, name is app 1. Labels app is app 1. One replica app 1. Okay, just for simplicity, not giving too much. Just app as app 1 and name is app 1. What is the image? Join DevOps / app 1 colon v1. Okay, so this is available already. And then service app as app 1. Service also app 1. Target port is 8. Okay, so that's it. So similarly for app 2 also, I'll create the same manifest. Instead of app 1, I will name as app 2. Okay, so 2 deployments and then 2 services, app 1, app 2. So now how to implement Ingress? So before implementing Ingress, so we need to set up Ingress controller. There is some process for that. AWS, EKS, Ingress controller. So the documentation is from official. This one. Okay, so this is the official documentation, but there should be some website for this. So that reference also. Okay, so this one, this is the official documentation. So I'll just mention here. Readme dot ingress controller reference. Okay, so there are multiple steps. First step, go to deployment. Okay, so these are the steps. You need to run these commands. That is our region code, US East one. Sorry if I extend the class today. EKS port cluster. Just run this. So this is called OIDC provider. So OIDC provider is nothing but the authentication between EKS and then AWS. Okay. So because they exchange the information coming out of this repo. And this is the OIDC provider. And after that, so we are giving access to our nodes to create load balancer. Okay. So this is the policy, or it's not the government. So this is different one. Okay. So while you are practicing, replace your cluster. Okay. So this is the policy that gives access to create load balancer. Okay. So you can see it is giving access to create load balancer, adding the target groups, everything. And then just create this one, policy. This policy maybe already exists in my account. Yeah, it is already exists, not a problem. And then this is finally this one. Cluster name EKS spot cluster. So it will create AWS load balancer controllers in kube system namespace. Okay. So region code US East one. And then AWS account ID is this one. Okay. Once that is done, you need to do this one. Helm charts. So you need to install the actual controllers that comes from Helm charts. And then the final step is this one. So when you do this, so this Helm is installing some controllers in kube system namespace. Okay, that you can see kubectl get pods -n kube system. So after all this process has been done, now EKS has got full access to control the application load balancers. Okay. So this is the setup. Now we need to create our ingress resources to inform Kubernetes. That is, there will be something called examples here. Okay. So this is the example. And these are the annotations. If you remember, I said in the beginning of the Kubernetes, labels are to select the Kubernetes internal resources like service to pod. Annotations are used to select the external resources. Like application load balancer is external service to Kubernetes. So we have to use these annotations. Okay. So now I'll take these annotations and let me get one more example of host path ingress. Okay, so let me just take this one and go for app one here. This is the ingress resource. I'm just mentioning it as app one, and this is in default namespace, internet facing application load balancer, IP based, and subnets we don't need to give, it will automatically take it. And then you can provide any number of tags here. Okay, the project generally RoboShop. So these tags will go and attach to the application load balancer. And then there is something called another annotation that is full annotations guide. So annotations plays a crucial role here. Yeah, go to annotations here. There is something called group name. So this is important to group, to mention this is for join DevOps. Okay. So your AWS cloud account can have multiple clusters and multiple ingress ones. So we are mentioning this is for the join DevOps group. Okay. And that is about the annotations. So now once annotations is done, we need to mention our spec. The spec, and just copying this one, or you just copy from anywhere in the internet. So ingress class name is going to be ALB. So Nginx is for actually on-premise load balancers. So let me take from here. So ingress class name should be ALB. We should need ALB to be provisioned. And the rules. So these rules you can consider this one as app1 dot join devops dot online. The request comes as app1 dot join devops dot online, and path, any path, just a path like this. Okay. And then path type should be prefix. So generally this example, there is no straight example actually here. So this one, you can consider this one. Okay. Host is join devops.online and HTTP request on slash any path. Okay. Prefix and which service it has to trigger. So which service it one, app one on port number 8. So we are informing EKS cluster if there is a request on app1.joindevops.online / send it to the app1 service. Okay, so this is it. Now push CK8 ingress pull. So CD app1 kubectl apply -f manifest. So now it is saying created. If it is successful, then you can come here and then see the load balancer is provisioning, and it will have two rules. So one rule, if there is something called app1.joindevops.online, forward this to this target group, and then here you can see our pod is coming and then registering itself. Okay? So just this one. There is your application load balancer will be created, an ingress resource will be created. This is attached to the service, from service to the pod. And this one, it's a rule here. Okay. Now let us do the same thing for our app 2 also. That group name is very important. Okay. Otherwise, it will create multiple load balancers. If you give the same group name, this is informing Kubernetes that so attached to the same load balancer. Git push, git pull. Sorry, today is really extended. Okay, so now it is created. Now, if you come and see here, there should be another rule. So app2.joindevops.online. So this is another topic. Now, if you come and check here, created two load balancers. Okay, two target groups. That is fine. So is our load balancer active? Still provisioning. It will take some time to provision it completely. Now, app1 target group healthy. App2 target group healthy. Now, if you just take this one, it is active. Now, what I do, I will go and then create raw 53. I'll delete the previous record. So now what I say is any request on star.joindevops.online, send it to our application load balancer. Where's east one? Okay. So now you can just take it and then go to anyone app one.joindevops.online. You can see hello, I am from app 1. And then if it is app 2, you can see hello, I am from app 2. So we successfully tested the request cascading with single load balancer. So here you can create RoboShop project, Amazon project, Flipkart project. So a single load balancer is effectively can handle the load between multiple projects. So this is about ingress control. Any questions? So while you're practicing, just understand the purpose first and then practice. Okay, otherwise you feel you are overwhelmed. Any questions? Okay, so you join today evening session, and then we will just summarize once again. Okay, I know it is too much because this is the advanced topic, RBAC, and then ingress, and what else we discussed today. Horizontal pod autoscaler. You don't think it has these two topics, you don't think it has too much because it is very common sense. We need to handle the load based on the traffic. So we just created one more resource with average CPU utilization. And this is RBAC is also very much simple. We just created roles, right? The only topic you may be confused is this one, ingress controller. I will repeat it once again. So any questions? If no questions, we can end the session. So before you practice, just understand the purpose and then practice. Then you don't feel it as a burden. Okay. Refer one YouTube video on the topic RBAC. Refer one RoboShop once you listen to our session. Or else first you listen one YouTube topic on RBAC, one YouTube topic on horizontal pod autoscaler, and one YouTube topic on ingress controller. So, and then you listen to our session so you can handle very well. So if no questions, we can end the session. Have a nice day. See you in tomorrow's session. Bye bye. So we can now start this complete workflow from Jenkins CI/CD. I'll implement Helm charts to deploy the application. I'll implement horizontal pod autoscaler. I'll implement EKS cluster. I'll implement ingress controller. Everything together now. Okay. So that's all for today's session. Have a nice day. See you tomorrow.